number operation could contain more than just addition, more than just multiplication, more than just division of numbers. A number operation could contain some or all of these operations in one operation, and that is called mixed operation. How should you, if you see such operation, proceed to getting the correct answer after evaluating the operation? Please follow me as I develop this last lesson objective of this topic, and that is lesson objective number 14. What is it? How to evaluate mixed operations. Operations containing some or all of addition, multiplication, and division. Simple as they are, they will serve as a bedrock, a stepping stone for us to proceed to other more complicated mathematical operations. It has been nice having all these sections developed step by step. It's also believed that in this final section, you apply what you have learned in other sections to carry out mixed mathematical operations. Please cooperate with me. In this final section of 14, we are going to learn how to evaluate mixed operations. I've defined this before. It is a type of operation, number operation, basic number operation that contains sum or all of addition, multiplication, and division. We're going to learn this by means of example to avoid too much talk. We say to evaluate a linear mixed operation, we use BODMAS. First, we have a mixed operation that is linear. Watch this operation. It is linear because there is no division in it. If we had said all of this over something, that would have been something different from being linear. But because along the same line, we have all the operations lined out, we call this operation linear operation, linear mixed operation. Why is this called a mixed operation? Watch out that here, between this one and this one, what is going on is addition. Between this and this, what is going on is multiplication. Between this and this, what is going on is division. It means that we have more than one type of arithmetic operation going on in this singular operation. Again, because this operation has many numbers that there are in this operation, they appear in one line. We refer to the entire thing as linear mixed operation. Again, we say to evaluate something like this, we use BODMAS. We learned BODMAS before now. It is a mnemonic, an acronym that was adopted by early arithmeticians who met a problem, a challenge in evaluating numbers in their operations. What was that? Like I said earlier, a single operation contains more than addition, multiplication, and division. It is a mixture of the three, either some of them or all of them. When such mixture occurs, it can be challenging to know which one is to be done first. Mathematically, any one can be done first. What it means is that those persons that encountered this challenge in the past had to resolve it among themselves as to which operation should be carried out first if there comes to be a mixture of these three basic operations, as we have in this case here. That is how they resolved that bracket should be treated first, that is B, and if there is a bracket after being treated, there comes off. If there is no bracket, disregard it and go to O. O refers to off, and off when interpreted, still refers to multiplication. Then D refers to division, M refers to multiplication, A refers to addition, S refers to subtraction. So, which means do brackets first, followed by off, followed by division, followed by multiplication, followed by addition, and followed by subtraction, the last one. That does not mean that in every case that contains mixed operation, that all of this must appear. How many are they? 1, 2, 3, 4, 5, 6. It is not compulsory that in a single linear operation that is mixed, that all these 6 must appear. It is some of them that may appear sometimes, and sometimes all appear. Whatever happens, this is the order. If you don't find any of them useful and applicable, discard it and use the others which are considerable to solve the problem. Now, let us use BODMAS to solve this. Don't forget that you don't apply BODMAS except you have a linear operation. In this first example, we have a linear operation. In number 2 example, we're going to see a nonlinear operation, or that which contains a nonlinear operation. Let us start with this first one. Please, having been told that BODMAS is to be used, is there any B in this operation? The answer is yes. Where? It is here. Therefore, it was resolved that bracket be treated first. Let's do it first. Watch out. Yes, that is what it has come to be. Minus 12 plus 30 minus 3 times 4 divided by 2. Only one thing differentiates this line from this line. What is it? This minus 12. It came from this bracket. This is why minus 12 has come to be here. That is, I'm owing 14, I have 2. After the cancellation, it is minus 12 we have. What next? Now, the B has been done. Is there O in this operation? No, there is no O. So we discard O. Is there D in this operation? Surely there is division. See it here. That means the next thing we do is to isolate 4 and 2 and divide. Let's do it. Yes, see that next line of action? Minus 12 plus 30 minus 3 times 2. What is this 2 coming from? When 2 divides 4, we have this 2. Don't forget that D is what we just treated. So B is treated, D is treated. No need for this O. So far, we are here. What is next? Is there a multiplication? After D comes M. Is there a multiplication? Yes, there is. This is 3 times 2. Let us do it. That takes us to minus 12 plus 30 minus 6. I hope you know how this minus 6 came to be. You should. Minus 3 times 2 will give us minus 6. So this minus 12 brought down plus 30 brought down. Then the whole of these 2 will become minus 6. What is next? We just did multiplication to get this minus 6 here. Is there anything like addition here? Yes, we have. That is between minus 12 and plus 30. Let's see it. And that takes us to this 18 minus 6. How did we get this 18? Minus 12 plus 30 means I'm owing 12, I have 30. So we pay from what we have. And what we have is more than what we're owing. So from this 30, we pay the 12. What remains is this 18. Therefore, out of these 2, we have this 18. Then this 6 is brought down to a minus 6. So now we're left with 18 minus 6. You can even tell what the answer will be. What is it? Let's see. Yes, there comes the answer. 18 minus 6 is equal to 12. What it means is that the entire operation here, linear operation, gives us 12 as the answer. Why is BODMAS important? It is important because without this regulation of BODMAS, anybody can start anywhere. And even if each person obeys the principles of mathematics, without recognizing this BODMAS, the answers that they will get will be different. And this person will claim that he is right. And you will not even blame them that they're claiming that they're right, because there should have been a regulation. Now we are happy that we have this BODMAS to regulate the way we carry out linear mixed operations like this one. Now, let us look at example 2. And this is example 2. It looks almost like the first one, except that divided by 2, which we had here at the end, is now everything divided by 2. Please, are we still going to apply the BODMAS? Partly, yes. Where? In simplifying the dividend, because this is divisor and this is dividend. The divisor is one number already, but the dividend is not yet one number. So in effort to make this dividend become one number, we see it as a linear mixed operation, and so we're going to apply BODMAS in simplifying the operation. Again, like before, let us use BODMAS to simplify minus 14 plus 2 plus 30 minus 3 times 4, so that we get one number which 2 will divide. Let's proceed. And that is what happens next. This is, from here we have minus 12 plus 30 minus 3 times 4 all over 2. I hope you know how this minus 12 came to be. Yes, you had it before. And now nothing new has happened. From minus 14 plus 2, we have this minus 12. And the rest appear as before. So that we have minus 12 plus 30 minus 3 times 4 all over 2 here. Now, what is happening? We are treating the numerator, otherwise known as here known as the dividend, with BODMAS, because that dividend is linear. Don't forget why we're doing it. It is not the entire division. It is not the entire operation that we are carrying out with BODMAS, but with this linear dividend alone. Let's go on. Bracket was treated. That is this. It came to be this. There is no off. We'll discard it. Also here, that remains. No division. We'll discard it. Next is this M. Is there M in the remaining operation? Yes. That is multiplication between minus 3 and 4. That takes us to minus 12 plus 30, then minus 12. See it here. I hope you know how we came to have minus 12 here. Yes, you should. Minus 3 times plus 4 is minus 12, then all over 2. So this has become this. I hope you're not confused. Let's see what happens next. We go back to BODMAS. We just treated this M. Is there a need for this A? That is, in this linear operation here, do we have a need for A addition? Yes, there is. See it here. Therefore, we're going to have it that minus 12 plus 30 will give us 18. I think you know why. Like before, I'm owing 12. I have 30. From my 30, I pay the 12, and then I have 18 left, which is what I have, not what I'm owing, giving rise to 18 from here, minus 12. See minus 12 here, all over 2, all over 2. Then next, the last one is subtraction. That is adding what you owe, adding what you owe. So in the end, we have 18 minus 12 to give us this 6 here, then over 2. Going to divide 6, the answer is 3. Therefore, the answers we get from mixed operations without using BODMAS will be different. even embarrassing. But because we have BODMAS, each time we apply it, we see that the answer we get is just like what other persons will get when they apply the same BODMAS. So far, let us find out whether we can solve more questions, more problems from the mixed operations. I ask to look out for a checkpoint. And here comes the checkpoint. It says, evaluate the following operations using BODMAS where necessary. Number 1, bracket 20 minus 15 minus 10 plus 3 times 5. Number 2, minus 3 plus 17 minus 3 times 2, all over minus 1, minus 1, minus 1, minus 1. Number 3 says 15 minus, in brackets, 2 plus 8 plus 20 divided by 2. Only 3 questions. I believe that I'm going to know how to go about them, possibly because you listened to me while I explained the principle and the process behind the use of BODMAS.